we will go into see what is the typical pipeline when you're trying to launch a deep learning application in production. So this is probably your scenario, okay? Let's say you're using TensorFlow, PyTorch, and any other frameworks out there. First of all, you will probably gather data, and then you get your data, and you need to extract and transform it, pre-process, and load, which is the ETL portion here. And then when the data is all being collected, transformed, and then it is ready to do training, model training, okay? I'm going to show what is training a model, what you need to know later. And probably you're going to code in Python, which is quite common there. You're going to do all this in Python. So up until here, this box, you have a train network. You have a train network. And yeah, it depends on what kind of framework you have, what kind of file. And then here comes the challenge. You need to deploy it. You need to find a way how to serve your model to do inferencing. Let's say you do a prediction. You need to serve your model, okay? That is the challenge. So one typical use case for today's session, let's say Android apps, you will probably go to the easiest one to refer, which is TensorFlow, like the serving tool, TensorFlow serving. And here is where you actually, usually, I've seen a few examples. First of all, you get let's say if your model is in TensorFlow, it is a protobuf, PB, you will convert it using TensorFlow Lite tool, and then you'll get a TensorFlow Lite file. And then from there, you will run it on your app. You will have an interpreter to make sense of the file here. And then you do the prediction. And again, this part, the inference part, is usually in JVM or Java. And also another example is where, let's say if you're using PyTorch, and PyTorch, I don't think there's a serving tool. If I know, is that you use PyTorch, you convert it to a TensorFlow kind of intermediate, where you're using a framework, not a framework, a tool called Onyx, ONNX, and then again, from that file, convert it to the TensorFlow-like kind of file, and then you deploy and do your inferencing. Again, the key point here is to deploy it. And inference means you run the model, you get the image, and you do the prediction. Okay, you guys know what's inference, right? Okay, not hard selling, but okay, let's say if you're trying to do a mobile app, if you're using deep learning 4J where you actually can code everything in Java, you can gather data in Java because production system, the data might come in your Java application, like big data or any enterprise kind of software. You get your data, you extract, you transform and load, you process it. And again, from here directly, you do the model training. Okay, then after you train the model, then the file can directly be deployed because again, it's still in Java. And after you deploy, you can do inferencing. Let's say you feed in an image, a string of numbers, an array of numbers, then you can do your prediction. Okay. Again, with deep learning 4J, you can do everything in Java. That's one of the perks of using deep learning 4J. Any questions here? Okay. So that is when you're trying to show off or deploy your application, those are the common scenario that you might meet. So some people nowadays you can download pre-trained weights, pre-trained models. You can directly run it and yay, good job. You can show something to people. But let's say if you're trying to train your own neural network, then these are some tips on how to do it yourself, right? You can either download pre-trained model and run it, or you can actually download pre-trained model, do transfer learning, and something. Or you can train from scratch. Depends on you. So some tips in training a deep learning model. Again, deep learning is very inspired by the human brain. Hence the word neural networks. It's like the units in your neural network is almost like a brain cell. So in your, like a brain, you have multiple units of computation cells, and one of it you can, something like this, we call it a perceptron. So when it's trying to learn, actually multiple perceptrons connect to each other to do the learning part. So if you zoom into the perceptron, this is an example of what a perceptron might look like. So you have inputs, and then you have the weights, and then you can sum it up and you add a bias. And then all this will go through an activation function. So you might heard of a few activation functions like ReLU, hyperbolic tangent, and sigmoid and stuff. And from this activation function is where you add the non-linearity into the equation, and then through it you get the output. Okay, that is one unit of perceptron. So a neural network is a compilation of all these mini perceptron working together. So a very basic feed-forward neural network is that you will certainly have an input layer and an output layer. Input in, output out, right? And then the key point here, which needs a lot of people to experiment it out, is the hidden layer. The hidden layer is where the actual learning works. Input come in, do all the learning, and output layer comes out. And the whole thing creates the whole learning pipeline. So when you increase the number of hidden layers, then it goes from feed-forward neural network, then multi-layer perceptron, then you can have different variant. You have convolutional neural networks, you have skip connections here and there, LSTM, yeah, it depends. So when you're dealing with deep learning models or neural networks, you have two phases in your development life cycle. You will probably do easier way is to inference, to use the pre-trained weights that people share online, open source, and you just run it. You make sure your input image go in and do the stuff, and then you get a prediction, the output. That's part of the development. Another kind of development is the training of a neural network, where a lot of work comes in where you need to collect the data set, and in some cases you might need to label the data set. Let's say you have an image of a cat, you need to tell that this picture is a cat. You need to do all those collection of data, labeling of that, annotation. Yeah, that's one thing you need to do. Gathering data, again, remember the pipeline. You gather the data first. Okay, then make this as a piece of process where you feed in your data, all your data already collected nicely, pre-processed, and then you feed into the training. In this training, you will have forward and backward propagation. And when you're doing this cycle here, how do you define learning? In a simpler way to show this is that, again, you have annotation, you have labels. Let's say this is a cat. It is true that this is a cat. And your code might predict that it is a cat. So you need to compare the results and get an error value or loss. So you do this for a long time, cycle through all the iteration, epochs and stuff, and until you reach a certain criteria, then you will stop training or stop learning. So you get the idea, right? So how does it learn? It learns from the mistakes like a human do, right? So forward, backward, you get the loss, you learn from it, then you update the weights when doing the back propagation. So when you iterate through different iterations, you go through multiple epochs. Epoch is like how many times you want to pass your data to train for a forward and backward pass. Yeah, that's one of the hyperparameters here. And what is the criteria to stop the training? It can be iterate until you reach a certain epoch, or you can iterate until a certain the loss, or the loss reaches a certain value. You can stop the training at a certain loss value. Let's say 0.001. You stop at that, then you stop training. Okay. Depending on you. Earlier on, I did mention hyperparameters. So what are these? You can call them as variables that determine the network structure, variables that determine how the network is actually trained. So a few common and key hyperparameters that you can tweak to adjust your final output accuracy is that, let's say, number of hidden layers and the number of units of hidden nodes. And like how you're gonna initialize your weights, that's one of the hyperparameters. And depending on what kind of activation function you use, is also a hyperparameter. Let's say some people like to use ReLU, then they just put ReLU. Then some scientists say that you can put 10H to get a better accuracy or something. Then another person might use 10H. These all hyperparameters that you can do all this tweaking to change your final accuracy. Let's say, again, I said that when doing training, you actually calculate the loss, and this loss is calculated using a loss function. And your loss function can be also another hyperparameter where you can set, let's say, categorical cross entropy or negative log likelihood loss function, and also the learning rate, which is like a lot of people like to tweak with the learning rate, and number of epochs, how many times you iterate your model training. It also defines how your accuracy will look like. And also, you have mini batch size where you pass in batches of images or batches of data into your network during training. These are the hyperparameters that can change your output accuracy. So you can play around and test it out to see which one you can get a good enough model that you might use later on. So to train a neural network, so in this case, is in terms of supervised learning where your data must be labeled. Okay, so a very simple example here is that what are features and what are labels. So let's say this is the data for a resume. Maybe an engineer will have a height of 180, weight, and gender male. So these are the features that have the class or label of engineer. So yeah. So for teacher, you might have this. This is all your data. It can be any kind of data. So this side is all the features. And the last column here is the labels. So let's say if I feed in a new line, let's say 150, 60, then male. So what label does it belong to? So in your classification, after you have a deep learning neural network, you will predict and guess that what occupation is this person. So that's why you have machine learning in this. You have data, right? You have more data, the better. You have features, you learn from these features, and then you define what's the final prediction class. Oh, so fast. Okay, so let me jump into the demo side of today's session. Again, I mentioned that I have two apps. The first one where we will actually train a neural network on an Android device on my laptop. It will take quite some time. So, ouch. Okay. While doing that, maybe while training the model, I'll walk you through in how does the project structure, how does it contain your code and structure and stuff. So yeah. Okay, again, to create an Android app, you guys can see the screen, right? Okay, so you'll probably use this IDE, which is Android Studio. Okay, so this is the second app. So let me open the first one. So so if you guys are interested to reproduce this project, how easy will it be? I'll show you later. And first of all, you open up the app. There's a lot of menus, a lot of toolbox and stuff. Okay. Again, today I will show you how does the code might look like and try to help you better understand what is actually going on. Again, I'm going to train the network later, so it might take some time because, again, you're training on an Android device, a low power device, and also it is a virtual machine inside my laptop, so it will take some time. Okay, it will take some time. So let me quickly spin up the Android device. So I have a virtual device here. It's named called Pixel 3 XL that I do not have. Okay, so makes sense, right? So I quickly spin this up and launch it up. Okay, one piece of advice here: if you're trying to do an app, right, make sure you have a powerful machine, because most of the time you spend is actually waiting for it to compile and do. So yeah, get a good machine, please. Okay, as you can see here, I can drag my Pixel 3 XL. You see, so fancy. It's like the real one. So this is running on Android Oreo. Forget what API level is that. So yeah. Okay. Ignore this. Come back to the code. Okay. So can you see this? There's a run button here, right? If I click run, what will it do? It will compile the app from source code and make it into an executable file and then install it on the virtual device. So there's a list of steps here. I'm not going to compile it here. It might take some time because I probably include everything into it and just throw it there. So I'm not going to do that. Instead, I have the app already installed on the phone. So I'm going to run it. You guys can see the phone, right? Okay, so this is my Pixel 3. This is the first app. Okay, back here. Again, a refresher. What does this app do? Again, you train a model and then you inference, meaning make a prediction. And what kind of prediction? It classify your handwritten digit and predict that what kind of digit it is. It's a very simple kind of app. Okay. It trains and evaluates an MNIST classifier. So what is MNIST? MNIST is a data set where you have all this data set, all the handwritten digits, 0, 1, 2, 3, 4, 5 out until 9. So it's a total of 10 classes, right? 0 to 9, 10 classes. Okay? And as you can see here, later I'm going to show you like you can draw something here and you click predict, then predict something like this. Simple enough. Okay. What does it do? Classify the user's handwritten digit. And for this app, which is not perfect, you can actually draw on any part of the screen. You can like draw until you reach until this button. Yeah, okay, just draw. Once you draw it, it will save to an image. And then you will do the prediction on this image. Okay? Okay. Come back to the code. Without wasting more time on the training, I've spin up this code. I believe. Okay. Have a sharp background to see more clearly. Ooh. Okay, very nice background. Okay, here. To do prediction, what do you need? You need the model, right? You need the weights. So now I'm gonna train my weights or train my model. So where do I store the weights? For this demo, I store everything to downloads folder because it's so easy to access. You can, when you create file, right, using the app, you can store it in internal storage, in SD card, or anywhere you want. Depends on you. So for me to clean up all this extra stuff, I put it in the downloads folder so it's easier to access and you can delete it easily. So again, let me show you where is the file. You go to Files, the File Manager, and these are a list of files here. I have I have a few files here. Okay, so the one here, MNIST classifier.zip. I know that TensorFlow is .pb and others might be others. So for Java, it's a .zip file. So I already have the model here. So if I draw something and predict, I will get something. So I'm going to show you that it actually trains, and I'm not doing any con job. I'm going to delete this guy. I'm going to delete. I'm going to really delete it. I think I deleted the correct file. Yeah. And then I go back here. And then I click train. Oh, it's training already. Whoa, okay, training on the phone. Yeah, it's going to take a lot of time because apps are not meant to train for now because we don't have super phones, right? For now. We may not know what happens later. So while training, it might take some time. So let me go through the code and nitty-gritty bits of the details. Okay, again, this app is a modified version of the actual example given by the official deep learning 4G example. I fork it, the repo, and I do the modifications on top. So yeah, the original one will do prediction only. For this one, I make it to be able to train the model and then do prediction. Because I want to prove that I can train on the phone. That's the main goal. I don't care how long does it take, but I just want to prove that I can do that. Okay, for now it's like that. So again, not to show that a con job. I have again where to see my logs. Okay, this is a actual device running right here with processing word here. So I'm not cheating you. Check the logs. As you can see here, it is actually training. Like you see the iteration, then this is the loss. It's actually training. Yeah. Okay. We'll come back to see what happened later. Okay. This is because I already filtered using the score word. Again, you can filter depend on custom filter, or you can filter by using the log level, like debug. Again, an Android phone is like a computer, and a computer has a lot of system logs, all those pieces, services working together to serve as a phone, right? So you can check out all these logs if you want to, but I'm not going to do that. For me, I'm interested on my app only, so I can filter it using my custom, either score or demo or something like that. Okay, enough of the logs. Okay, so I can close it like that. Okay, this is a typical Android Studio feel of the IDE. Again, if you want to reproduce this project, very simple. Easy to put. Okay, I need to go here first. Okay, so just now earlier on, I shared on what are the dependencies and how to train a simple neural network. You will need the data, the data set, right? You need it. And okay, I have two sets of data here, which is the handwritten digit data sets. They come in a very weird file extension, which is ubyte. Okay, not common. I have two sets of data here. I have a trained data set and a test data set. And I have, for each set, I have two files. Remember? Features and labels. Features is the characteristics and all those details about a certain class. And labels is like the class of what kind of class? Engineer, teacher, whatever classes you want. So this is trained data set, meaning you train on data that this trained data set, and test data set, what is it used for? It is used to evaluate how good is your model. When you do training, right, you can't test it on the same data set because that's like cheating, or it's cheating, basically. So you would want to test your model on unseen data, I mean new data. So that's why I have a test data set. So my model is gonna train, and then test, evaluate how good is the algorithm. Okay. If you want to reproduce this, I have a link here. You can type bit.ly/MyMNIST. I will give you the files to the the train model and also the test and train data set. You can download it to your phone and try say, hey, maybe my phone train faster. I don't know. You can test it yourself. I'm not stopping you. And yeah, how to reproduce? Simple enough. Download the project, open your Android Studio, open it as an existing project. Make sure all your dependencies are already done. No more red lines and stuff. No critical red lines. Maybe there are some red lines there you can be ignored. So yeah, make sure all the critical red lines are already cleared. And then make the project, compile it, and then you run the app on your phone or on your virtual device. Maybe you can get also a Pixel 3 XL, right? Oh, okay. So let me briefly run through the code. Okay, this is the structure. We have a manifest file. As you can see here, because due to time, I'm going to fly through it. Okay, you can ping me offline or whatever. Yeah, do you remember that I said that you need to specify your default activity here? You see main. So this is your main activity. For this example, I have only one activity, only one, which is very default name, main activity dot, it's a Java file. You see this, dot Java. So this is the backend code or the logic behind it. And again, manifest. Here, I only ask for the permission of reading and writing the external storage. Reading is because I read the files, and writing meaning I train the model and save it on the downloads folder. Because I choose to put it in the downloads folder, I need this permission, external storage. If you choose to save it in internal storage, you might not need this permission. Up to you. Okay, speeding again. Manifest done. Okay, grader. I emphasize this a lot because it is the thing that slows me down early on. Okay, there are two grader files. One is under the module and one is under the project. There's a project grader or a module grader. So you can briefly know what those two are different as. So in the project one, usually you have short, very short, and for this module is where you import different modules. For today's session, I import deep learning 4J module because it's available in Maven. That's why I can do all this. You see that I have set the minimum, blah blah, all these versions and stuff. A few notation that you need to put, and this is where I import. I have a few core components, and because of today's session, I import all the available libraries because, again, I'm not sure that what device that I'm going to run. Let's say in my virtual device, on this guy is actually using x86, like Intel kind of CPU. When I use on this guy, Huawei phone, is using ARM. So I try to compile everything so that it works. Okay. So a few important modules that I need to import is deep learning 4J, the core components. If you're doing computer vision or deep learning, you probably touch on OpenCV. So I'm gonna import it anyways. I'm gonna import it, and I have NG4J, which you use for the training, right, and also inference, where your matrix multiplication, all these calculation is being done using this library for the computation. And again, I told you that I import everything. Why? Because I have, again, Android. Okay, for this is ND4J only. I will import ARM64. Remember 32, 64 bit. You have ARM64, x86, and 64. Right. This is only for ND4J. Then I do the same thing for OpenBlast, OpenCV. I have a few here. I put it all there because that, let's say if you want to reproduce, and I'm not sure what is the target device, right? Yeah. If you feel that it's too slow, it's compiling taking too long, you just remove the lines, okay? And you will work. You just test it out. Okay. Enough of the minimum stuff that you need to do. let's jump into the actual code. So object-oriented programming or Java, you will have something like this. Your file, your package, you can import all these modules, right? Typical programming way. And then because I have deep learning 4J module already successfully imported, loaded, I already sync my Gradle, I can just call all these API. This previously we are running on Java machines, but now I'm going to run it on the Android way of Dalvik machine and stuff. Basically, again, Java, JVM, Android also can support Java. Then I just try. Again, you import all these all these dependencies, and then you do the main stuff. You have a main class, a main activity. In your main activity, you extend this class to get all the basic app methods that you do, like jumping around. Jumping from activity to activity and showing logs, showing toast messages and stuff. Yeah, you can look into it later on. And yeah, wait, let's see whether it is finished training. Oh, finished training, awesome. Not very long only. Anyway, yeah. Okay, again, I'm not cheating. I'm showing my screen here. If you check the model, it should be here. Yeah, see? What is it? 1209. Yeah. Now you have the model here. All right. So again, more on the code. Yada yada. Okay, you set your permissions here. Right. You set it on the manifest, and you also need to set it here. Why? Because that's how Google wants to do things. And then again, my UI. Okay. Again, this is my backend code. So if you can see here, I have a button. I call it the train button. Click it to train the model. And I have also another button where I have to do the prediction. Okay. And yeah, all the tiny little functions, or in Java we call methods, to do the underlying work. If you can see here, okay. And you have a lot of overriding because you extend a certain class and you override the certain method to make it work according to your use case. And for Android, because there's UI and also backend logic, you have threading. You have the main thread is actually a UI thread, and you can actually do something called async task, which is something like this. You extend this thing, which you actually make the workload go to the backend. You just create another thread and you make it run on another thread. Okay, right? Yeah, that's one of the things. And again, here, this is where I create a neural network in deep learning 4J. I'm not sure you guys did. I'm pretty sure that you guys built your own networks already. And this is how deep learning 4J way of doing model building. You see here, you have your first layer, which is a convolutional layer, and you have this subsampling layer is actually what we call pooling layer, and then you can define your weight, how you're going to initialize your weights, and again dot list, which is making something like a sequential kind of graph, and you have dense layer and output layer and stuff. Yeah, you can create anyhow you want, but for this MNIST, we'll create a very simple network, and the accuracy is quite good already. So yeah, this is how it looks like. You see, this is how I code it. Okay, and then you initialize, then you train it. You train it across a number of epochs that you set, and you have actually I time all the time used for this, right? And and this. Because Android, right, you have a lot of functions, so you need to learn a lot of mini functions to make something. Let's say you want to do like press the button, download something, then you need to import and use some specific classes which is good at something, right? This is the way of how you create apps. You want to download stuff, you want to scan QR code, you import a certain class to do it. This is how you do it. Something like Python as well. Yeah. Enough. I think this you can read it yourself. Again, you see this. Action down, action move, action up. What is it? It's my hand press. And save drawing, save it, do prediction and stuff. Okay, for this is simple because it's only one activity and show you the UI, which is here. Oh, sorry, there's a folder called REST. What is REST? Resources. So layout. So this is my activity. So you see, very fancy drag and drop way of doing stuff. See? Okay, drag and drop. I'm not going to do that. So this is my entire UI. How I'm going to move it around, how I'm going to place it. Yeah, I can move it here. I'm not going to touch so much about it. Yeah, this is the UI. So I mentioned that you can do drag and drop. Very fine. And if you're not the kind of person you like to do it in text, you can also actually do that. I'm not sure why would you do that. Okay, you can do something like this. You can code your way out of it. Up to you. Again, back end work done, front end work done, and then you link it. You link it where? You link it here. If I find activity, main. Yeah, I will set that my current activity will be using a certain layout, which is this. If I click here, I'll jump into here. Okay, that is the clearest way of explaining stuff. And then, yeah, back to the app. Okay, some prediction work finally. Okay, so I'm gonna, on phone you use your hand. For me, I'm gonna use my mouse. I'm gonna draw a simple one. Why is it like that? I don't know. Oh, one. Oh, yeah. Luckily. Okay. Before this, let's see what's the output logs. Why is my UI like that? Okay, demo. The text is too big. I'm going to show you that the model is being loaded and stuff, but yeah, don't care about it. You will see it when you do it yourself. Yeah. So let's do more of this fun stuff. Two. Two. All right. So I'm going to do this. Name a number, please.
11.
Oh, 11 cannot. 11, I'm going to do it another way. 8. 8 is a very hard number, so let's see it fail. Hey. Oh my god, my 8 is very ugly. What should I say? 3. Change this model. Anyway, yeah. Let's use a more significant. 3. I actually tested it out to see which one is a good one. 4. Right? Not bad. Not bad, right? Okay, not gonna do anymore. Okay, so yeah. For the first step, I've already done. As you can see here, I call all my data, I put it all into my phone, and then I train it, and I get the model file, the weights, and then I do my prediction. I load my weights on my model, and then I do my prediction, which is a handwritten digit classification. Okay, enough of that. Let me jump to the last app, which is, I'm not going to close this anyway. Alright, okay. Running out of time. Okay, so the second app is TinyYOLO object detection. So again, object detection is to detect an object and know its coordinates in a frame or image. So for this, I'm not going to train it because it'll take I don't know how long, very long. Instead, I'm going to use this for prediction only. So it's very, very minimal UI. See? Very minimal, 2 buttons, that's it. I don't care, just to make it work. What I'm going to do here is actually I download a trained model, a pre-trained TinyYOLO model, already done by some other researchers. I have the model. I'm going to load it and do the prediction directly. I'm not going to do any training. So for this app, prototype, I have 2 modes. One is real time, where you open up the app, you try to find something already. And the second one is where you capture an image using your phone, you get an image, and then you feed into the model and it does the prediction. And what kind of prediction? Object detection. Again, I'm going to share this. How to reproduce it, download the source code, open it up, resolve it, make project, run app. So for this, I'm not going to do training, so I don't need data sets. Instead, what you will need is the model, the trained model, the pre-trained model. TinyYOLO is the topology or the architecture used for this research. And another file is called the label file. Because when you do detection, when you get the object, it's not called like, let's say you find a cat, then it's not directly saying that, oh, this thing is a cat. Actually, it's detecting that, okay, this is a cat, but it is class 0. And then what is class 0? 0 is like the index to a database to show that what object is this. Maybe cat is 0. So when you found 0, you change it to cat. And let's say you find a dog, which is class 2. Then so what does 2 mean in this label file? Dog. So you will rename it as dog. So you get the whole idea. When you detect it, it won't directly become cat or directly become dog. You need to refer to a certain list of labels, right? For this, Android Oreo, when you set permission to write to the storage, you need to be quite strict. So I can't do it for Android Oreo, but I do it for my phone, which is Android Nugget. I can do that. But for this, I need to explicitly open up the permission and set it here. Because for this, I'm going to access your camera, and I'm also going to I'm going to create file and save it to your phone. So make sure you allow access to your camera and storage. Okay, this is how it's going to look like. Okay. Again, this is my app. You can see here, this is an app here. The real time, okay. So you might be guessing, right? Oh, this is a virtual device. So if you open your camera, where does it look at? They have like an environment which is all created objects where you can roam around. Yeah, a virtual world inside there. Okay, so I'm gonna click single image. Is where you capture one image and then you do the prediction on this image. I'm gonna click it and yeah, ready to load. Okay, see, this is the virtual world where I can walk around. This is actually the sweet spot which I anchor already, but never mind. I'm gonna walk around here anyway. So it's like a kitchen here, Yeah. Take 2 steps back. Yeah, I'm gonna run around. Okay. And come back to my sweet spot. Okay, this is so far, right? Okay. So in your real world, you have this app, then you do your stuff, right? Okay. So choose the picture that you like. Okay. Click the capture button. All the sound. Okay. Click it. Okay, now here. Oh, okay. Something went bad. So yeah. Let me try again. I hope it goes. Okay. This is the preview that I show here. Okay, again, phone nowadays we like to say 20 megapixel, 60 megapixel, so big the image. But when you feed the image to your neural network, it's actually being resized. For this, let's say my actual phone, I can capture 12 megapixel. I actually resize it all the way to 416 and 416 dimension. Why? Because the model expects this size of image to enter it. Okay, yeah. So when you do all this resizing, some information or some compression, maybe the ratio is off a bit, then the accuracy might run away a bit. So yeah, take note of that. Okay. And yeah, for this, as you can see here, this is not drawn by me, obviously. It's actually, you get the results and then you draw the bounding box to show where is the object. So for this, you see that this piece of thing, this part of the image is a sofa. very obvious. So, okay, one more thing is that you might notice that, you have multiple sofa for this and it's very annoying, a lot of noise. Actually, I can fit into one algorithm which is called non-max suppression to make it to become only one box. But I'm not going to show here. So for this, right, once I capture, I do the prediction. This is just the preview. So I actually save the file in your downloads folder, which is the non-resized folder, a non-resized file. As you can see here, not sure how to zoom here. Yeah, basically you can see that so far, yeah. That is basic. Again, basic object detection. Yeah. And one more thing. I have real time. So I'm not going to show it on this device because it's very slow and frames are coming in very slow and the detection is slow. Again, in terms of deploying models, you must make sure that your performance is good enough to make it accurate. Okay, so I'm going to probably run it on my phone. But my phone is also not the best phone. It's 3 years old phone. So I'm going to load it and share some. So again, I'm not cheating. YOLO object detection, I'm going to click real time. So okay, very smooth, right? And again, deep learning is a very compute expensive process. So yeah, but you're going to let it load the model. You're going to load the model and do the prediction real time. So I'm going to tell you when it's done. Okay. Okay. I'm not sure any object here. So you see, it's very slow because I'm actually loading quite a big model into this example app. My bad. I should use a more smaller model or do some optimization. But again, this is prototype, just come out quite hot. Yeah. So I need something to show that it's working. So can you
tweak the front camera? Do you have front camera?
Oh no, I didn't code it that way. So yeah. Do you have a phone or something or a human? Okay, can I use a volunteer? Can I use a human?
Yeah, but people cannot see. Yeah.
Slow. Again, slow. So person, you see that, right?
Oh yeah.
Person. Okay, great. So it works. Anyway, that's not the main highlight of today's session. Okay. Today's objective is to show that you can actually do deep learning on mobile. Okay. Again, few reasons you need to. I'm going to end it short with some Q&A and also some stuff. Very slowly, very fast. Again, take note of some gotchas where we will stop you from reproducing stuff. Is that if your virtual device storage is too small, then you will keep failing to install the app. And if you have something called multi-desk disable instant write. And again, if you reproduce, remember that you need to clean out all this rubbish, unused stuff. You just go to downloads and picture folder and delete all them. Okay, so you have seen that, it's so slow. How are you going to use this? That's not the end, right? It's the beginning. So how do you make it faster, as per se? First of all, you can try something like converting the input or the trained model into a lower level machine code. And for example, like how TensorFlow do it is that they convert everything into something, a byte buffer object. Okay, it's lower level, so I guess it's faster. And again, today I'm using TinyYOLO model, which is 59 MB. Compared if you use an example code you get from GitHub from TensorFlow, the model is like 4 MB only. So my model is actually 20 times bigger. Yeah. Again, use a smaller model if you can. Maybe try something like MobileNet V2 SSD, right? And then you can perform optimization as well. Let's say you make your code to run faster on a certain special AI chip. Nowadays it's all AI chip, right? So you can do that. anyway software kind of optimization, and also you can make your code to use lower precision floating point. Usually it's FP32 by default, and you do some conversion, you will use FP16 or FP8. Okay, gonna end soon. So conclusion. Reasons why do you want to? Oh, sorry, I was gonna start. Why not to use cloud? Again, cloud is very happening right now. And if you know that some, let's say, voice, when you talk to Siri or you talk to your Google Assistant, what it actually does is you record a voice and you send the data upwards and you get back the result, something like that. Where you send the data from your phone to the cloud and then you do the prediction on the cloud server will do the prediction, and then you send the prediction data back to your phone to get your output. Why not to do that? Personally, I feel that running your prediction or inference on the cloud is expensive. You need to, first of all, it's expensive, it's hard to set up, and to maintain it also costs a lot of money, unless money is not an issue. Right? So if you go to somewhere with bad network coverage, then it will lead to high latency, slow frames, or even down of service. So I would say that edge inference is the way to go, is because high demand. Everyone has a phone. It's like another hand of yours, right? It's always in your phone. So if you want to do all this AI fancy prediction stuff, the best is that you have the data coming in, doing the inference on the spot. Then no worries, you're independent on all the others cloud servers or any other stuff. So for this link is guide you to all those examples that you can find online on GitHub. And again, they have a main repository for DR4J examples, and also we have a forum community for deep learning 4J guys, where the public can go in and ask good questions again. Yeah. Again, thanks for coming today. I guess some people saw it through Meetup or Facebook. If you are keen to join some more this kind of sharing session, you go here and just sign up. And Facebook group, which is quite new, just go in and add yourself in, and you can get the latest news.
Yeah, and today's slide, it's already we're going to share our slide into the Facebook group as well, and also like all the photos that we're going to share, and we'll keep update all the related information about deep learning, machine learning, data science topic on the Facebook group, and welcome you guys to join and share more contents. We want to form the community of deep learning and share all the knowledge. So just click in and it's thank you.
All right. Some desserts, right? Desserts. Okay, so Skymine is putting a huge effort in creating some training costs for the public. Again, like what Tencent, you guys know Tencent, the people behind WeChat. Okay, they mentioned this in an article saying that there are 300,000 AI engineers out there, but millions are needed. So this kind of skill set is quite rare. Although you can see everyone like, a lot of people know, but the actual skill set is quite rare as well. So people, to get it more specific into this kind of topic, you should get a certification. Again, AI is so broad. Everyone might be focused on doing some particular work. It can be like data science kind of work, core programming, or you just do deep learning. And also, again, getting data is hard, labeling is hard, and pre-processing it to make it fit to your environment, your programming environment is also hard. So you will need data engineer as well. Yeah, so that's the reason why you need to get certification to begin your career. So there's a few training that we will be providing in the future. Now it's not yet launched, so this is like a sneak peek. So we have data science course, RPA, which is robotic process automation. A few guys doing it. And also, other kind of course where teach you how to use Skymine products. And once you complete all this certification, like any other course out there, you will have a badge to show in your LinkedIn, or you get a cert and stuff. Yeah. So I'm gonna end this sharing session. Before I end, Please give me some questions. Why is there no questions here? Is it that you lost your event code? Okay. All right.